So as we talk about complex roots of equations and factoring over the complex numbers, we're going to do these very similarly to problems that we have done with real roots and factoring over real numbers. So a few minutes ago, I gave you these two warm-up questions. So somebody tell me, how did we start off with the first one if we want the quadratic with lead coefficient 1 with roots 5 and negative 4? Avery, how'd you start? And is that all you did to set it up? Equals, what does it need to equal? It needs to equal 0 to have roots. Factoring only works when the factors are equal to 0. So I take x minus each of those. That would mean either the first parentheses is 0, x minus 5 is 0, so x is 5, which was one of the roots. X plus 4 is 0, so that would mean x is negative 4. So we've got both of the roots that we were given. If we then FOIL this out, that's where the 1 comes in, so that we get 1x squared minus x minus 20 equals 0. Check my math there. Did I get that right? So we took x minus the first root, x minus the second root, equals 0, FOILed it out, and got the equation. Process for the second one. What did you do to set it up? Same process or something different? Natalie? Same process. X minus the first one, x minus the second one, equals 0. So x minus 2/3, x minus, and if I take minus that entire root, I've got to remember that that means I am distributing that minus sign, so I'm taking the opposite sign of both of those. And that's equal to 0. And then I would FOIL all of that out so that I have x squared equals 0, and that would be our process. So I wanted us to do those to review the process. Any questions so far? Okay, let's do exactly the same thing now, except this time the roots are going to be complex. I still want a lead coefficient of 1, so I'm still going to take x minus the first one, x minus the second one, equals 0, and then I'm going to need to FOIL out what I get. Now I have to be careful. X minus that entire first root changes both of those signs, so I have x minus 3 minus 2i. And x minus that entire second root changes both of those signs. First line is optional. If it helps you make sure that you don't make mistakes with your plus and minus signs, write the parentheses around those roots in there. If you can just do x and then change both the signs, x and change both the signs, you may jump straight to the second line. We can either write this out horizontally, x times x is x squared, x times minus 3, and so on. Or you may find it more helpful on some of these to use a table. So we're going to do the x, the minus 3, and the minus 2i for the terms that we have in one of those parentheses. And then I'm going to do a column down the left side for the terms that I have in the other one, which those were x minus 3 and plus 2i. Those are not part of my answers. My answers are just going to be the things that I get inside. Those are kind of my headings for the table. My answers will be what I put in here. If I take x times x, I get x squared. X times minus 3, I get minus 3x. X times minus 2, I get minus 2x. And remember, I is always last. Now, if I take minus 3 times each of those, I have minus 3x, I have a plus 9, and I have a plus 6i. If I take plus 2i times those headings at the top, I get plus 2x times I. 2I times minus 3 is minus 6I. And 2I times minus 2I is minus 4I squared, or positive 4. Then I'm going to look and see which things can I cancel in here. And let's see. The 2xi and the minus 2xi cancel, and the minus 6i and the plus 6i cancel. So if I put all of those things together, I have x squared, and then I have a minus 6x, and then I have a plus 9 and a plus 4, so I have plus 13 equals 0. And that is my quadratic equation. Lead coefficient is 1. It starts off with 1x squared. It's equal to 0, so I could use my quadratic formula, and these should be the two answers that I get. So far, so good with that? So if I started off with, here's the quadratic, and I didn't know what the roots are, I'd first say, can I factor it? Let's see, things that multiply to be 13 and add to be negative 6. Doesn't work, I'm stuck with quadratic formula. Since this is equal to 0, I'd say, okay, quadratic formula, x is the opposite of b, so 6, plus or minus the square root, b squared would be 36, minus 4ac, so minus 4 times 1 times 13, all over 2a, so 2 times 1. So I'd have 6 plus or minus, so I left out my 4, b squared minus 4ac. I said it, I just didn't write it down. So 36 minus 52 is how much? Negative 16? So that means I have 3 plus or minus 4i over 2. And those are the roots that I had, 3 plus 2i, 3 minus 2i. So those were indeed the roots of that quadratic equation that we came up with. So any questions there? So if it says write the quadratic equation, these are the complex roots, you've got to do the parentheses, parentheses equals 0, and FOIL things out. Sometimes they are going to ask the question a different way around. Factor this over the set of complex numbers. Do I know what that is equal? Can I solve that? I do not know if that equals 0 or if that equals 27 or that equals negative 19. It does not tell me, so I'm not going to solve it. I'm just going to get parentheses, parentheses, and stop. In order to do that, I need to temporarily imagine that it does equal 0 so I can use the quadratic formula. So I'm going to let A be 1, B is 10, C is 41, and say that that means x is the opposite of b, plus or minus the square root of b squared, 100, minus, this time I will write down my 4 times A, so times 1, times C, so times 41, all over 2 times A, so 2 times 1. So I have negative 10 plus or minus the square root of, say, 4 times 41, 164. So 100 minus 64, we have negative 64, and that's all over 2. So negative 5 plus or minus 8i over 2. So plus or minus 4i. So if this had roots, that's what they'd be. It's not really equal to 0, so now when I have factored it, I need to take x minus each of those roots that I just found, but not equal to 0, because I don't know what the real problem equals. So I'm going to plug these in. So I'm going to take x minus, one root was negative 5 plus 4i, the other root was negative 5 minus 4i. And I am going to clean it up just a tiny little bit. I'm going to distribute that minus sign so I don't have parentheses inside of parentheses. X plus 5 minus 4i, and x plus 5 plus 4i. Not equal to 0. I don't know what it equals, so I just stop there. You may write this top line if you wish, or once you have the roots, you can say x, change this sign, change the top sign. Next parentheses, x, change this sign, change the bottom sign, and I've got the factors. I'm not going to take your time because I know you want to get to the homework. If we FOILed that, we would get exactly this. X times x, we'd have x squared. Others would cancel and combine. Questions for that one? Okay, there's another type that you have to be a little bit more careful with. And this is my last example for you guys, and then we'll get on to homework time. So we want to factor that. So first we look at it. I don't know, maybe it can be factored over reals. Reals are just special complex numbers. Anything you can do with real numbers to start factoring that? Eva, what do you think? Is there anything you can do with just real numbers? So first we're going to factor out the GCF. It is the greatest common factor. It is a factor, so we are going to keep it. 2 times x squared plus 2x plus 5. So our final answer must have 2, and then we're going to have some factors in it. And I'm going to show you an easy mistake to make on these and how to watch out for it after we do this the correct way first. So now I am using A is 1, B is 2, C is 5, because I can't think of any real factors that multiply to be 5 and add to be 2. So I'm stuck going to the quadratic formula now, even though I don't really know that this is equal to 0, I'm just factoring. I'm going to say, well, x could be the opposite of b, so negative 2 plus or minus the square root of. B squared would be 4 minus 4ac, so 4 times 1 times 5, all over 2a, so 2 times 1 is 2. So 4 minus 20, I've got root negative 16. So that means I have negative 2 plus or minus 4i over 2, or negative 1 plus or minus 2i. Does that look right? That means my factors are, if you want to do it the short way, you can say x, change both of these signs, so plus 1 minus 2i, and x, change this to a plus, change the bottom one now, so both of those are pluses. And those would be my factors. If you think you're less likely to make mistakes, it's okay to write x minus the negative 1 plus 2i, x minus the negative 1 minus 2i, and then distribute those minus signs to get this. And that is the correct answer. However, I want to model what happens if you forget and don't notice the GCF. You are going to get it wrong on the factoring. If we did not notice that, if we did a equals 2, b equals 4, c equals 10, and jump straight to the quadratic formula, we would get x equals the opposite of 4 plus or minus the square root of, b squared would be 16, minus 4 times a is 2 times c is 10, all over 2a, so 2 times 2 would be 4. So we would have negative 4 plus or minus 16 minus 80 would be negative 64, all over 4. So I would have negative 4 over 4 would be negative 1, plus or minus 8i over 4 would be 2i. And so I got the same solutions, the same roots, but if I just did this and I tried to write down my factors, I'd say, oh, x minus this first one, so plus 1 minus 2i, and x plus 1 plus 2i. If I FOILed this, x times x, I'm going to get something that starts with x squared, and I'm supposed to have factors that give me something that starts with 2x squared. So that 2 is a necessity in there. You've got to have it. So when you're doing these, do that much of the FOILing. X times x is x squared. Oh, that's not what I needed. I must have forgotten a GCF, so write it in. Makes sense, just for a check to make sure you get it right? Any questions on what we've covered today?